Okay, so chapter 8. Chapter 8 has 6 sections, and the mid-chapter 8 exam is over just 8.1 and 8.2 because the problems take several minutes to solve. So 8.1, 8.2 is all we have to
Bless
cover.
you.
The schedule right now is to have the mid-chapter 8 exam next Friday because it only covers 2 sections.
Next Friday?
Wait, covers 2 sections.
Next Friday?
Next Friday. Then the end of chapter 8 exam, you're
I'm coming
looking
down
at
with a
the
cold.
first week of May. And
Please
then
don't be May
the final
3rd.
exam, you're looking at the second week of May. Okay? Next Friday? Okay. Well, remind me that next week and we may regroup. All right. We are back to actual math. I hope y'all are locking in with me, please. Please lock in with me. Put any distractions away. We're back to math with numbers, no proofs. You do have to be able to do those proofs for the final, but right now you can tuck it away and be like, all right,
Skipping the
back to numbers. I personally love 8.1, 8.2 because there's formulas. I love formula, plug it in, you know what I mean? So I think you may enjoy this. When you first look at it, you're probably going to think it's a headache, but it's actually really not that bad. And of course, we're going to practice it for 2 weeks. So we're going to have plenty of practice. Before we dive into the new stuff, let's refresh you on something from geometry, which we did at the very beginning of this semester. And that would be solving a right triangle.
Can you just let us go?
Let's
do this.
Then do it. Do it. I'm talking right now like to help in case you forgot. If you hear solving a right triangle, it means find all 3 sides and 3 angles. Now, in this particular picture, we have what type of triangle? It's a right triangle. So one of the angles is by that little box, 90. And then, of course, if you look at the picture, you've got other info given to you. First of all, your calculator needs to be in what mode? Degree mode, because we're dealing with degrees. So make sure it's in degree mode. When you're solving a right triangle, let me give you this phrase. It's a rhyming phrase. You've heard me say it before. I'd like you to write it down because it's going to come up in the new stuff. Go to what you know. Go to what you know. And what do I mean about? What do I mean by that? I'm going to say the most about. Let's say that. Go to what you know the most about. We got sides, we got angles. Looking at the picture, I know more on the angles. So let's find the missing angle because that would be the easiest. If you recall, how many degrees are in a triangle total? 180. You might want to write that down somewhere. Total degrees in any triangle, doesn't matter what type of triangle, any triangle is 180 degrees. That's important. So I can find angle Z by simply taking 180 and subtracting off the right angle and the 37.1. And I get 52.9. Then I can come over here and I can label that. So this is 52.9 degrees. Now now I need to solve for the missing sides. Okay, this is geometry. We're coming back to trig, basic trig. Let's write the formulas here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. At this point, looking at the picture, it's a matter of which one you want to solve for first. You want to solve for the Q or the W? Somebody pick. Okay. So if we're going to solve for W, I'm going to use a highlighter here to draw your attention to it. If I'm solving for W, then that means that's my variable. I need to set up a trig function. I've already got a variable. I need two more numbers, right? One of them is going to be an angle, and one of them is going to be the other side. I'm going to have to use the 6.3, and then you have the choice of 52.9 or 37.1. You don't use the 90 in sine, cosine, tangent. You should remember that. You don't ever use 90 with sine, cosine, tangent. Let's think smarter here. Which one should I use? Let's use the 37.1 because it was given to me just in case I messed up the 52.9. So you're going to always see that I use the info that was given over what I found, just in case I make mistakes. All right, so now that we've got your attention on the fact that I'm shooting for W and I'm using 6.3 and 37.1, label your triangle according to the angle you're using. I like to draw an arc on the angle I'm using. I like to draw an arrow from the right angle to the hypotenuse so that I know that that is the hypotenuse. Ask yourself, how is the 6.3 positioned to the angle I'm using? Is it opposite or adjacent? It's adjacent. And a way to check that is if you trace it, did you touch the angle you're using? Yes, that means adjacent. If it had been over here and I don't touch the angle I'm using, it's opposite. So this is adjacent. And then, of course, the W is the hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So we're going to set it up. Trig function, angle measure. That's not 3. Angle measure equals fraction mark. The formula is adjacent over hypotenuse. 6.3 over W. The W is in the bottom. If you recall, do you remember what I draw? Yes. It's like an elbow arrow. Do you remember that? It's down here. I need to cross multiply that to the front. And then I've got this. I don't have W by itself, so what do I need to do? I need to divide this to the right. And now I can type that in my calculator. 6.3 divided by cosine 37.1. If this is unfamiliar for you, then that means that you need to practice it because what we are about to do is very similar to this. We're just going to have a different formula. So this should be familiar. So when you type in your calculator, W divide, or no, 6.3 divide cosine 37.1, let's go to the nearest tenth.
7.9.
7.9. Alright, we've got one side left. You have the freedom to choose two different ways to solve for Q. What's one way we can solve for it? Same thing we just did. You can use trig. If your focus is now Q, I like to keep the same numbers, right? But now it's not cosine, it would be tangent because you're using opposite and adjacent. If you don't want to use trig, what's another way? Pythagorean theorem. I personally don't like the Pythagorean theorem. I feel like I run into more decimals along the way. I like trig. I can see trig faster. Especially when you set up the fraction and the variables in the top of the fraction. So we're going to cross multiply 6.3 over to the front. And that would give us what we can type in the calculator. Going to the nearest tenth. Did you get 4.8? Okay, that is solving triangles from geometry. Okay, you're finding all three sides, all three angles. We are doing the exact same thing, solving triangles. The difference is they're no longer right triangles. Okay, so when you first learned this in geometry, you probably learned you can only do this with right triangles. That's true. Sine, cosine, tangent in this manner can only be done with a right triangle. But now what we're going to do is look at oblique triangles, acute triangles, which means angle bigger than 90, an angle less than 90, all three angles less than 90. If you have a highlighter, there's a lot of information on this page, and I've highlighted the stuff that actually to try to like draw your attention to it. There are 5 scenarios for solving oblique triangles. Oblique means that it's not a right triangle, okay? Basically think of it as non-right triangle. You've got angle, angle, side, which means in the picture you're given information on 2 angles and then a side on the outside. You've got angle, side, angle, which means you're given info on 2 angles and the side in between. You've got the one that's starred, which if you spell it in the other order is a cuss word, side, side, angle. Side, side, angle, just like if you work in customer service and someone's being an arse, we'll do the British word. How's that? We'll do the British one. If someone's being an arse in customer service scenarios, you don't know how to deal with them, right? You just want to get them out. That scenario goes into a whole slew of possibilities. Then there's side, angle, side, and then side, side, side. Okay, what scenario do you notice is not up there of letters?
Angle.
What? Angle, angle, angle. So basically there's no AAA roadside service, okay? And this slide is letting you know the reason why there's not. If all I know is the measurement of the 3 angles, that doesn't actually tell me the context of the triangle I'm working with. And here are 3 counterexamples. All the angles have the same measurement, but clearly the triangles are totally different sizes. So angle, angle, angle will never be solvable. And that's because you've got to have at least one of the sides to kind of get a context of what kind of triangle are we working with here. All right, so let's dive right into the first one, and it's not side, side, side. We're gonna work with angle, angle, side, and angle, side, angle for today, okay? All right, the first thing you need is to know what are our formulas. We are no longer doing the whole sine, cosine, tangent thing. Right? You with me? Instead, we're doing this. Law of sines. Law of sines will let you find the length of the side, or an angle, using these formulas, and the triangle does not have to be a right triangle. Notice that this is drawn intentionally to not be a right triangle. Notice the formula has 3 fractions. Right? And then you've got the 2 equal signs. With me?
Okay.
This might look confusing because every time we've had an equation, how many equal signs do we have? We just have 1, right? You got the left equals the right. This is letting you know that you can pick any 2 of those 3 and set them equal. That's what it's saying. It's saying that if you take A over sine A, it will equal B over sine B, or it'll also equal C over sine C. So you just take 2. Don't write all 3 fractions every time. Never write all 3. Just take any 2 that you need. Look at the picture. Let's make sure you know how to label your triangle. Notice, let's make a note. Notice sides are opposite angles. They're opposite, it should say from angles, yes, or of. Opposite of angles. So here's what I mean. And I'm going to draw arrows, but I'm going to erase them because it's going to get busy. But basically, notice angle A. If you go to the side opposite of it, you have little a. All right, now notice angle B. You go to the side opposite, you have little b. Angle C, go to the side opposite, you have little c. That's how you label your triangles, okay? So if I give you a triangle and I say, hey, you got triangle EFG, then little e would be opposite angle E. Little f would be opposite angle F. Little g would be opposite angle G, okay? One thing you do need to make sure that your calculator is in degree mode. And let's make a note. Choose 2 from those fractions. You don't write all 3. Just pull 2 of them. Now, what 2 do you pull? The 2 that you, one that's going to have the variable in it, and the other one needs to have no variables at all, right? All right, so let's look at the first example. In triangle EFG, little e, 4.56. This means angle E, 43 degrees. Angle G, 57 degrees. Solve the triangle. Well, the first thing we need to do is draw a picture. Let's draw a picture. Don't draw a right triangle.
Can I draw an
Now,
obtuse
I
triangle?
would not draw obtuse unless they told you an angle is obtuse. Right? You also know, remember what we said. Let's write it one more time. Go to what you know. Go to what you know. You know more angles or more sides?
Sides. Wait, angle. Sorry.
Thank you. You know more angles. We have 2 angles. We only have 3 to find, right? We We already got 2. Doesn't matter if it's obtuse, right? Acute, doesn't matter, right? It's the angles add up to what? The angles add up to 180. So immediately I can find angle, now I've got to look at your letters. It's E, F, G. I've got E and I've got G, so I'm missing angle F. So angle F is going to be 180 minus, you got 43, 57. You're going to have to show your work. This exam will be on my math lab. However, you're going to have the problems printed, like you're going to have blank paper, and you're going to show your work, and I can give partial credit along the way. Now, my math lab's going to mark the whole thing wrong, but I can go back and say, no, wait a minute, they actually got angle F right. They just messed up on the 2 sides, so I can go in and give partial. But I can't give partial if you're not labeling your work. Like, don't just come over here and say 180 minus da-da, and then write the number. Like, I need it labeled. Angle F is this. You know what I mean? So, make sure you're detailed. What'd you get? 80? And then I would prefer it if y'all would circle it or box it in so it draws my attention to it. Okay, so now we can draw a picture, and we also can draw a picture knowing that it's an acute triangle. You got 80, 43, 57, so nothing's bigger than 90, you know what I mean? So I'm just going to draw, I just like to draw a big old triangle. Now we're going to label it EFG. Of course, this matters too. It matters how you label it. Now that I have my triangle drawn, I'm going to fill in what I know. Here's where I like to use colored pens. If you're the type of person that doesn't mind doing that. I like to use black pen for what I know, what they gave me, and then a color pen for what I'm finding. But that's just me. You don't have to if you don't want to. What do I know? Well, I know angle E is 43. I know angle G is 57. Yes, I just found angle F, but I'm not going to write it in black because, that's not what they gave me. I found it. Little e is 4.56. Go to angle E, pretend like it is a light beaming, go to the opposite. So if this is angle E, then this is little e, 4.56. Then I get a colored pen, and I come in and I make letters for the sides I need, or the info I need. This is little g, and this is little f. Of course, I found angle F already. All right. We've got to find G and F. Don't you dare say Pythagorean theorem. Pythagorean theorem is only one when you have 2 sides and you need a third. 2 right triangles. This is not a right triangle. You'll never use Pythagorean theorem on these because these are on purpose, not right triangles. Here's where having a highlighter is helpful. Okay, I'm trying to teach you coloring techniques. Go to what you know. What angle and side do you know together? Like you know the side, you know its angle. What?
What?
E, right? Do you know angle E?
Oh, yeah.
Do you know side E? Yes. We're going to call that our anchor fraction. Okay? We've got to have, if you think about it, we're going to pull 2 of these fractions. One of them is going to have a variable in it. The other one can't have variables, otherwise we're stuck, right? So I like to get a highlighter, and I like to highlight the angle and the side that I know. They have to correspond, by the way. That's why I didn't highlight 57. They have to correspond. I need angle E, side E. And then now I make up my mind which one you want to solve for first, G or F. Doesn't matter, which one? G. Okay. So focus your attention on G. Now up here, the formula is A, B, C. Down here, my letters are E, F, G. Does it matter? No. Basically, the top of the fraction needs to be what? The lowercase, which means sides. The bottom of the fraction needs to be angles. Okay? Top of the fraction's side, bottom of the fraction's angles. Now watch how I set this up. I like to start with the one I'm solving for. I'm trying to solve for side G. Alright, side goes on the top, over, sine angle G. What's angle G? 57. Equals fraction bar, anchor fraction. You highlighted it, fill it in. Side 4.56 over sine 43. Side over sine of the angle that it corresponds to. You only want two fractions, you don't want three. You can't do anything with three. And now you have, go back to geometry. Now you have a proportion. This is why I love this stuff. This is a proportion. How do you solve proportions? What? Cross multiply. That's it. Now sometimes you only have to go one time. Sometimes you have to cross multiply and then move something. So I'm going to cross multiply this over here and this over there. Now be careful. Remember, sine of an angle stays together. Don't multiply the angle by a side length. Okay. Think of them as blocks moving across. You with me? So this would be G sine 43. And this would be, I like to put the side in the front, 4.56 sine 57. I need G by itself. What's in the way? Sine 43. So I'm going to move that to the right by what? Division. Now you might be, now I know some of you might already see it. You might be like, why did you do that? I'm going to show you. Hold on. So I'm going to move this by division over here. And now I can type in my calculator. Now, did I have to do cross multiplication from both sides?
No.
Not really. The only one that needed to be by itself was the G. I'm just showing you, what is it? Think smarter, not harder. So when you see a proportion, sometimes you can avoid cross multiplying both sides because then you end up just moving it right back a division. In this case, the only thing that needed to move was the sine 57. But now, can you see how it pops over to the right? So over here, I really didn't have to multiply sine 43 over. I could have left it alone. I could have just multiplied sine 57 up. And that's what you type in your calculator. Okay? We are definitely in the decimal world, so you're going to get decimals. By the way, if you would round to the nearest hundredth, let's go to the nearest hundredth. I'm going to leave this one here where I kind of did more work than I needed to. And then I'm going to show you with solving for F where I can do less work, the only work I needed to, so you can see the difference between the two. Did you get 5.61? over here, I'd say that this is 5.61. Now I need to solve for F. So remember law of sines. We're going to do F over sine angle F. What's the angle F? 80 equals fraction bar. Here comes your anchor fraction. This is why it helps to highlight it, because it gets used, hence the name anchor fraction. We got 4.56 over sine 43. Now, this time instead of doing the whole cross multiply both sides, because we saw how that was really not necessary, recognize which one actually needs to be by itself. F needs to be by itself. This is division. I'm going to cross multiply. I like to draw my arrow to remind me where it's going. It's going to cross multiply over behind the side length, sorry. And I'm going to write it here. You really don't have to if you don't want to, but it will help with partial credit. And that's what you would type in your calculator. You get 6.58. What do you think? That was the first example. They don't all last that long. I always say don't judge it, by the first or second example.